Reception's already started. We got a triangle built. Year's gotten started. Yes, I'm gonna have to match you in stature again. Right. Alex has started. George has started.
By units, do you mean like just put the letters that they use?
Units, like back when we were talking velocity, meters per second. Units.
Oh, is it force notes? Yeah, right.
Record your notes. Record your notes. The answers in your notes from yesterday for sure. That was the very last slide, Uriel. That was the very last slide that we covered. The last piece of your notes from yesterday to answer that question.
Did I pass?
This way, still a lot of chit chat, not a lot of writing. Start. Like it. Start. $30 more seconds. Finish up what you got. You're looking back at your notes from yesterday. Good discussion. Right. Use that triangle. What's the F stand for? F is force. What are the units for force, Amy? She's going to look back in her notes. We'll be right back to her. What does the M stand for, Uriel?
Mass.
And what are its units, Jonathan?
What?
Units of mass.
KG.
kg. What does that stand for?
Kilogram.
Kilogram. George, what is A?
Acceleration.
Cool. And Marilyn, what are the units for acceleration? Small class, everybody gets a chance. Okay, look it up. We'll be right back to you. Amy, have you found the units for force? M times G does give us a force, it does give us weight. That's on the right slide. What was the title of that slide that we were talking about yesterday? It was named after the guy in charge of our whole unit. Okay? And they abbreviated the units of force for him. What do they call him? They are called newtons. That is correct. Way to stick with it. Marilyn, you there? Meters per second. Squared. Okay, meters per second squared. Okay, what are the three formulas that come out of here? What are the three formulas that come out of our magic triangle? Alex, can you give me one of the formulas that would come out of our magic triangle?
M times A.
Yep. M times A equals S. That's a good one to choose. That was the easy one, right?
Yeah.
All right. Jerry, give me another one of the formulas that comes out of this triangle. F divided by A equals math. Cool. And let's go ahead and give me the last one. We've been given F. We've been given F. We've been given M. How do we solve for A?
For A,
Yep.
Two.
That's
would it be M divided by M or M times M?
which you covered up.
Yeah, it's the division because it's binary product.
Good. Okay, so here are our three formulas. You will need these today. Definitely need these today. Mario, can you read today's objective?
Through writing and speaking, I will be able to use Newton's second law of motion to be able to solve for acceleration and support.
Cool. Mauricio, how does this connect to what we did yesterday?
Newton's law of motion.
Cool. Most specifically, which of Newton's laws of motion?
First one.
Second
The
one.
first one.
The first one?
Second one.
Cool. Cool. Jonathan, you're going to disagree?
I disagree because yesterday we took notes on the second, we did the second on the.
Cool. So if you look back at your notes on Newton's second law of motion, what is Newton's second law of motion?
Direct relationship between force, mass, and acceleration.
So that, right? Feel like we're Newton's first or Newton's second, sir?
Second.
All right. What do you have to do to be able to be successful by the end of today, Stephanie?
Be able to solve this derivation mathematically.
Cool. So you got to be able to solve these three. Like, all right. So, why should you care, right? We've got Newton's second law of motion. Why should you care? Okay? So your weight's different here, your weight's different on the moon. That's kind of an interesting fact, right? We all know that. We should be able to calculate that. We can do that using Newton's second law. Okay? You can compare engines and cars. If you want to know whose car ought to win in a drag race, all other things being equal, you should be able to just compare specs and have a pretty good idea. Okay? Airbags, crumple zones, if you're trying to figure out if your car is safe enough, if you're wondering how designers work things out, this is definitely something that they work with all the time. Okay, accident analysis. I know that most of you guys know Freddie and Saul and the rest of them got in the accident last year, right?
Yeah.
And I guarantee you that there's not a single one of them that walked up to the officer and said, hey, we were going 106 miles an hour, and then we turned the car over and stuff happened. That is not the way the analysis went down, right? They said nothing, and the cops came to them and said, you were going 106. That's all CSI. That's all coming out of Newton's second law. Cool? All right? So these are reasons that it becomes interesting, but it really is just cool to predict motions and changes in motion, and that goes back to the big idea for this whole unit. That's really what this whole unit is about. Okay? So, we're going to do a 1-1-1. So you're going to silently consider for 1 minute. You're going to write down your reasons for 1 minute, right? You'll have 1 minute to talk it over with your shoulder partner, and then we'll have 1 minute to discuss the whole class. You're going to decide which object you think would be able to accelerate the best and what reasons that you have. What are we about to do, Jeff?
We have 1 minute to answer the question, and then we have 1 minute to share with our partner, and then 1 minute to share with us.
Perfect. All right. So here's the object. There's a man being pulled by a horse on a skateboard. Good time. Okay? There's this tiny little arrow being released from a bow. And there's this sprinter releasing herself from the blocks, getting going. I want to know which object you think would be able to accelerate the best, and what reasons do you have? Try and take it back to the formula. 60 seconds, go.
Yeah.
On your own, on your own, on our own, 60 seconds, write down your reasons. So I see Jenny writing down the reason, I see Mauricio writing down the reason. Alex is considering. At 30 seconds, try and have at least one reason written down why you feel like your choice is the best. Sway has a reason written down. Mario has a reason written down. Jerry, you need to get something written down. 5 seconds, finish your idea. 60 seconds, talk over your choice and your reason with your neighbor, see if you agree or disagree. If you disagree, try and convince your neighbor. If you agree, see if you have the same or different reason. 60 seconds, go.
I said the horse because it has
I hear Jonathan talking to Yuri. Here's Sway talking to Mario.
Yeah, the city force, it has a force, so like,
goes super fast there.
so like a man on skateboard pulled by a horse,
The
like,
horse can't
Yeah, I usually quit.
and then the friction too, because of the skateboard
can't accelerate that
pulling,
fast.
and but then the arrow, she's getting pulled back, it has no force, like nothing holding it against. Yeah,
What do you think?
it's just like, nothing's holding it back,
Yeah, it's not an
it's just
external
being
force.
released.
There's no external force.
And
This is the skateboard is the
Three quarters.
like the external force that makes it go slower.
Oh, Mr. Falky, you're in here? Oh, that's funny.
Oh, that's funny.
Good to see you too, Jessica.
And then the arrow's light too, so like it has a.
All right.
Small mass.
Show of hand. Straight up show of hand. A. A is the greatest acceleration. No? No horse? No horse? No horse? No Oil Spice commercial? I'm a horse? No? Thank you for one person. The arrow? Ooh, a lot of hands on the arrow. Anybody say the sprinter? Cool. Tell me why. No, it's fine. Why'd you guys pick the sprinter?
We just decided that. I changed my mind.
Okay, well, let's go with the crowd. Okay, I like the deference to a lot of people maybe possibly being right. But what were your reasons?
I wasn't here yesterday, so.
True, true. What do you think, Dr.? Why did you guys choose the sprint? Cool. All right. Why did we choose the arrow, Jonathan?
It's lighter and it's just being released. There's nothing important with that.
Okay, so bringing it back to the formula. It's lighter. Which one of these variables is that?
Mass.
Okay, so if I make mass really small,
Is it this one?
right, I can get a lot more acceleration from the force. Does that make sense?
On my statement, I said that the horse, because it has like a.
Ooh, I like where you're going with that.
And it has a bigger force than the arrow.
Man, it's like he predicted my next question. One minor change. Which object do you think has the most force? So, 30 seconds, because spoiler alert sort of happened. Okay, 30 seconds, which object do you think has the most force? Just pure force, power, what has the most force? 30 seconds on your own, and then we'll talk it over. 30 seconds on your own?
No, yeah.
Yes, write it, write your reason. 30 seconds, write your reason. 30 seconds, write your reason. Force. Go read forces.
That's the horse. I mean, it's big and
Yes,
has bigger
why don't you
mass.
take your phone, go over, take a picture of all the vocab.
I mean, like
You already did
the
that?
arrow is just like a straight line. It's not really,
Oh, you already have it.
and it's small.
All of them?
And
Because
it's
we covered like
sprinter.
7 yesterday.
Just pushes itself off.
Everything past the first one.
Pushing it.
So, everything after the Newton's first law, the elephant to Baki. Okay, 30 seconds, discuss with your neighbor, I'm pretty sure you agree, but let's find out. 30 seconds, discussing with your neighbor, I'm pretty sure you agree, but let's find out.
Force, has a greater mass.
What did we say? What did we say?
What did you put?
What's force?